the I'll call that the pink graph at the top. It's probably a better description of that color, but that's our mobile app effectively, and the throughput that's being monitored by the the front end gateway, let's call it, into our organization. And so mirroring kind of the layers that I put from left to right on the previous slide. Next down are our ACE integration servers, and so they're the next layer of interaction with that mobile application and our core banking system at the back. And so they are providing 3 replicas, so in a resilient pattern of deployment across 3 different worker nodes. It would be in cluster. You do want to deploy these instances in an anti-infinity kind of pattern, so that we're not holding two instances on any one worker node, and we'll see the effect of that in a moment. Our MQ layer is next down. You'll see we've got 2 queue managers here. We will actually deploy a 3rd one when we scale out the application in a little while. And so the MQ layer is effectively handling the traffic between the integration layer and the core banking app. You can see at the back in the very bright pink. In fact, that is a true pink color, I guess, or mauve maybe, on the next layer. And then right down towards the end here, we have a notification service. And so this is an additional feature, in fact, that we're going to add into the application. So, and we'll talk about that in a little bit down the track. And so that change will be kind of rolled in at the same time as we do the MQ upgrades, which is part of the demonstration scenario as well. So the first thing we're going to do, and I'll just flip to a couple of other tabs here. Let me just move that out of the way. So we have our Red Hat OpenShift Container Platform web console, which is providing us with, in this case, a pod view. So there's an awful lot of pods in a single namespace here. We'll be interested in just the pods that are running our application, because we're going to sort of interact with those in a little bit as well. And we've got a couple of Git repositories which hold the configuration for all of the application or integration components that you see here. So from a cloud native perspective, we've got sort of the source of truth in terms of both, the description and assets that drive the configuration, as well as the actual infrastructure in terms of the containers that we're deploying at the same time. So we're going to look at those briefly as well. So the first thing we're going to do is simulate the update to the worker nodes. And so what we're going to do here is just referring back to our application graph, is we're going to affect the ACE layer here in a fairly significant way. So we're going to bring down one of these integration servers effectively, and that would happen as a consequence of upgrading a worker node. And so I'm just going to choose the middle one. It doesn't really matter which one we use in terms of the demonstration. And so to do this, I'm going to go into my OpenShift Container Platform pod view, and I'm just going to filter on that integration server name. And so here it is. It's running. It's happily running away in the background. So what we're going to do here is effectively just simulate the worker node that it is on being updated, and so and see the effect that has on the infrastructure. So the way I'm going to do that is on the right hand side. I just select the menu. I'm going to just delete this pod to simulate that that rolling update of the worker node themselves. Obviously, there'd be other workloads on the worker node that would be affected, but in a highly resilient pattern of deployment, we don't expect this to affect the application. So let me just click delete on that. We'll see that that's terminating. And so what we should begin to notice is a drop in traffic throughput. And as you can see, that has occurred. So we're down to 0 basically on our middle integration server. You notice the other two, of course, now taking the extra traffic. So that the routing that happens through the internal OpenShift service allows us to, without affecting, as you'll see, the mobile application throughput whatsoever, the outage that we've seen in the ACE integration server infrastructure. And so because we've stopped or deleted the pod effectively, what happens is that OpenShift will automatically restart that for us. And so what we will see now is that the integration server in the middle is starting up. It's already starting to take traffic. And in fact, you'll see that the loads eventually on the ACE side of things will start to even out. And we're seeing that quite nicely, actually. And as you can see, a little bump there in the mobile app, but effectively mostly a very, very straight line across the top. And indeed, the same down here in the core banking application. So we saw, MQ start to move as the integration servers balanced. The workloads across the MQ queue managers were balanced as well. And so they took basically the workloads from the first and the third integration server, and let me just keep Siri quiet, and then everything kind of flattens out again. So let's do the same thing with MQ, just to show you the native HA capability and the failover of that. So we're going to just again grab the name of an MQ pod in this case, and we're going to filter on that name in our pod list. In fact, let's clear the filters and then do it again. Sorry. In our there we go. In our pod view in the OpenShift console, so you can see UCQM2 has 3 instances of pods running in a native HA capability, but only one of them is actually doing any work. So the other 2 are in standby. They're in a quorum based on sort of the raft principle. And so the other 2, I'm going to again simulate a node outage and take down this pod. And so the other 2 will then resume the processing of this queue manager. And so importantly, again, to your question, Paul, about either completing or rolling back, even if the queue manager is in mid transaction here, the state of the queue manager will be known by the other 2 instances of this queue manager in a native HA configuration, because they're all kept in synchronization again across boundaries of MQ transactions in this case. So a put or a get will either be completed or rolled back depending upon where it was in that interaction with from the application, which in this case is the integration service. But that completed state or that incomplete state will be mirrored in the other 2 queue managers, and so they maintain that transactional integrity. Let me delete that pod, the running pod, and we'll quickly go back to our web UI, and let's just keep an eye on all 4 windows if we can. You'll notice now that that running queue manager had a dip, and the dip was compensated for in the other queue manager. But you notice how quick the recovery was, and that's because we're using that native HA technology. And so there was a rebalance from the integration server that was attached to the UCQM2 across to UCQM1, and then once UCQM2 became available again, which was effectively just a failover to one of the other instances of that queue manager, the service was continued, but service to the second queue manager was restored. And so that little bump is all you kind of saw there. A little bit of rebalancing on the core banking at the back end as well. These are move on. this is now we're moving to effectively releasing a new version of the integration solution. So we're going to add the MQ streaming queues feature, in fact. As I say, very useful for that and other use cases, of course, for monitoring and so on as well. We are going to trigger that from a source code repository, and I'll just show you what that looks like. So this is a queue manager configuration template. You'll notice that aside from the fact that it's YAML, everyone very familiar with MQSC script will recognize this bit, and also the QMini we've incorporated in the same what we call config map object. So you can pass in the queue manager configuration to a new queue manager, an existing queue manager, or change that configuration via a config map change. We are going to alter this queue and add a stream queue notification configuration to it. At the same time, we are also going to change the version of the queue manager. So we notice that whilst we make the application change, we may as well update the queue manager to from what it is at the moment, which I think we go back to our web UI is 9300, and we're going to move that up to 9310. Just a note here, I mentioned the license service before, so the license annotations and the information around the deployments are actually taken from the same configuration YAML, so there's no need to do anything else other than deploy your queue manager with these annotations, and the license service picks that up for you. All right, to do that, I just hit the deploy button effectively on the screen here, so it's nicely convenient. And so let me just do that now. And so we should see a rolling upgrade of the queue managers, and there'll be a ripple, of course, a ripple effect through that. So here we can see that we're in an upgrading status, and you see the upgrade 1 of 3, which means no effect at the moment, of course, because in terms of throughput here, because the running pods are still in effect. Yeah, it dropped on actually both of them. Let me just, there we go. Yeah, so there we go. There's the load. Like it now, yeah. There's one we've still got. So QM2 became running and ready because the one that was updating here became running and ready, and so became running, and so we had 2 members that were able to vote, and this instance of QM2 was then put as the running pod.
Yeah.
And nicely, we see that we're up to 9310 on both queue managers there. Oh, and we have the notification service running now as well. So that update rippled through, and not just updated the queue managers. We're kind of interested in that, but also created the notification service, so we can see that we've added a feature at the same time, which is quite nice. Now we're going to scale application. So let me say is just to hit the scale button. Oh, so here we go. So the ACE servers are starting to, I know they're just going through a little bit of a bump there. Here we go. So here's our new queue manager. Okay, so at the end of that now we can see